You can either define a set by listing the elements in it. Like here I'm saying, let A be the set 1, 2, 3. And the way that we denote a set is with this curly brace, and then we put commas between all of the things that are in the set, and then we close the curly brace. Or, so that's what's called just listing the element. That's one way. The other way is you can just describe the set. And what's important here is that however you describe the set, it be unambiguous in terms of whether or not something should be included in the set. So if I just ask you for an example of a set, it should be relatively straightforward. Let B be the set of all even numbers. It's a perfectly good description. What else can we do? If possible, we can just explicitly list them out. That's not possible here because you can't just list out all the even numbers. It takes forever. Now, even though I've given you these as numbers, it's perfectly valid to think about things that are not numbers. And in fact, I think that for the purposes of building our intuition, it's better. Even though this is a math class, that doesn't mean we only work with numbers. I could say, when we're defining a set using words, we can just think about describing a criterion. For instance, I could say let X be the set of tall people. But wait a minute. This is terrible. Or at least it's not valid, because tall doesn't have a definition. And this could be a matter of opinion. For something to be a valid set definition, we need to have a clear criterion for establishing whether or not something is included. Different people might have different ideas about what tall means, and so this word is a problem. Instead, we can make this, let X be the set of all people who are taller than 6 feet. And this is clear, this works, this is objective, this is measurable. We will all agree who should be in the set and who should not. So the criterion for something clearly being a set is you want it to be clear whether or not a proposed thing or object or whatever, whether or not a proposed thing is a member of the set. If I say let X be the set of all good songs, that does not work. Or it's up to opinion. What's a good song? Who decides? Now, if you say let X be the set of all, let's think about how could we change that criterion so that it would work and it would actually define a set while still meaning at least close to what we originally intended. So instead of saying all good songs, because who knows what that means, what if instead we said something like, let's X be the set of all songs that have sold at least 1 million copies in the US by January 26th, 2022. And now here is something we can actually determine whether or not something is in this set based on this criterion. Another way we could do it is we could make it still be dependent on opinion. If we could still tie this to a person's opinion, but we could make it be one person's opinion. So we could say, let Y be the set of all songs that Dr. Penland thinks are good if we ask him on January 26th, 2022. Both of these would be acceptable definitions. And these are not ambiguous. These are things where we can actually determine whether or not the membership criterion is met. This idea of a set having a membership criterion or of something being a member of a set is really important. So I want to go into it in a little bit more depth. So let's say that we have a set, and I'm going to call it B. If B is a set, we write X is in B to mean that X is included in the set B. So this is new notation. This new notation is used because it is helpful to have as shorthand. It's cumbersome to keep writing is an element of or is a member of. This notation is really powerful once you get used to it. So as an example, let's suppose we have the set B equals 1, 2, 3, 4. So these are the 4 elements of B. It is true that 1 is in B. It is true that 2 is in B. And those are the only true statements I can make using these symbols B and the in operator. On the other hand, not true that 5 is in B, so we would write 5 is not in B. So this symbol kind of looks like a C with a line in it, and you can think of that as contained in, is used when something is a member, is included. On the other hand, we use the crossed out version of that same symbol. So I draw the C with the line in the middle and then cross it out for not contained in.